Welcome to Agentic AI Design Patterns. In the next few minutes, we'll explore the 4 foundational design patterns that transform large language models from simple chat interfaces into autonomous agents capable of complex reasoning and action. You'll learn the reflection pattern for self-improvement, the tool use pattern for real-world interaction, the planning pattern for multi-step reasoning, and multi-agent collaboration for complex problem-solving. These patterns are the building blocks of modern AI engineering. Let's get started. Let's start by understanding what makes agentic AI fundamentally different from traditional LLM applications. The shift from traditional LLM usage to agentic AI represents a fundamental change in how we build AI systems. Traditional LLM usage follows a simple pattern. The user sends a prompt, the model generates a response, and the interaction ends. There is no iteration, no self-correction, no ability to use external tools, and no memory within a task. The quality of output is limited to what the model can produce in a single forward pass, with no opportunity to refine, verify, or act on the result. Agentic AI uses LLMs within iterative loops that enable reflection, tool use, planning, and collaboration. The agent can evaluate its own output and improve it. It can call external tools to search the web, run calculations, execute code, or interact with APIs. It can decompose complex problems into multi-step plans. And multiple specialized agents can collaborate on problems too complex for any single agent. 4 design patterns form the foundation of agentic AI. Each addresses a different limitation of basic LLM usage. The reflection pattern enables an agent to evaluate and improve its own output. After generating an initial response, the agent critiques it, checking for errors, completeness, and quality, then generates an improved version. This loop can repeat multiple times, with each iteration producing better results. Research shows that even simple self-reflection can dramatically improve code generation, writing quality, and reasoning accuracy. The tool use pattern gives agents the ability to interact with the real world. Instead of only generating text, the agent can search the web for current information, execute code to verify calculations, call APIs to retrieve or modify data, and perform file operations. Tool use transforms the agent from a text generator into an actor that can accomplish real tasks. The planning pattern enables agents to decompose complex problems into manageable steps. The agent analyzes the overall goal, creates a step-by-step plan, executes each step using reflection and tool use, tracks progress, and replans when obstacles arise. Planning transforms agents from reactive responders into proactive problem solvers capable of tackling multi-step challenges. Multi-agent collaboration assigns different aspects of a complex problem to specialized agents that work together. A research agent gathers information, an analysis agent processes it, a writing agent drafts content, and a review agent provides feedback. Orchestration coordinates their work. This mirrors how human teams solve complex problems through specialization and collaboration. Now let's see how these patterns work in practice with concrete architectures and examples. The reflection pattern follows a generate critique refine loop. Let's trace through the architecture. The cycle begins with the generator producing an initial output. This could be code, a written document, a data analysis, or a strategic plan. The generator uses the original prompt plus any context from previous iterations. The initial output is rarely perfect, which is exactly why the reflection loop exists. The critic evaluates the generator's output against defined quality criteria. For code, the critic might check for bugs, edge cases, and style. For writing, it checks accuracy, clarity, and completeness. The critic can be the same model with a different prompt, a different model, or even an external tool like a code linter or test suite. The generator receives the critique and produces an improved version that addresses the specific issues identified. This is not starting over. It is targeted improvement based on concrete feedback. Each refinement cycle typically produces measurably better output. The course demonstrates how 3 reflection cycles improved code correctness from 65% to 92% in benchmarks. After refinement, evaluate whether the output meets the quality threshold. If it does, deliver the result. If not, loop back to the critique phase. Set a maximum iteration limit to prevent infinite loops. In practice, most improvements happen in the first 2 to 3 iterations, with diminishing returns after that. Choosing the right pattern for your use case is critical. Here is a practical selection guide. Code generation benefits enormously from combining reflection and tool use. The agent generates code, uses tool use to run tests and verify correctness, reflects on any failures, and iterates until all tests pass. This combination achieves significantly higher code quality than single-pass generation because the agent gets concrete feedback from test execution. Research and analysis tasks benefit from planning combined with tool use. The agent decomposes the research question into sub-questions, plans a search strategy, uses web search and document retrieval tools to gather information from multiple sources, and synthesizes findings into a coherent analysis. Planning ensures comprehensive coverage rather than superficial search. Content creation at scale uses multi-agent collaboration with reflection. A research agent gathers source material, a drafting agent creates initial content, an editing agent refines style and clarity, and a fact-checking agent verifies claims. Each agent uses reflection internally. This pipeline mirrors professional editorial workflows and produces higher quality content than any single agent. Complex decision support requires all 4 patterns working together. Planning decomposes the decision into analytical components. Tool use gathers data from multiple sources. Reflection ensures reasoning quality at each step. And multi-agent collaboration assigns specialized analysis, financial modeling, risk assessment, stakeholder impact to agents with appropriate expertise. Let's close with the most important lessons for agentic AI design. First, if you implement only one pattern, make it reflection. Adding a self-critique loop to any LLM application dramatically improves output quality with minimal engineering effort. Research consistently shows that even simple reflection prompts, asking the model to check its own work, produce significant improvements in accuracy and completeness. Second, tool use is what makes agents genuinely useful, but each tool is an attack surface. Code execution tools can be exploited. API tools can leak credentials. File system tools can access sensitive data. Apply security controls to every tool, sandboxing, input validation, least privilege access, and output sanitization. Third, planning is essential for complex tasks, but plans must be adaptive. An agent that rigidly follows an initial plan without adjusting to new information or obstacles will fail. Build replanning checkpoints into your agent architecture so the agent can adapt when reality diverges from the plan. And fourth, start simple. A well-implemented reflection loop outperforms a poorly designed multi-agent system every time. Add patterns incrementally as your use case demands them. Over-engineering with all 4 patterns when reflection alone would suffice adds complexity without adding value. That wraps up our overview of Agentic AI Design Patterns. In the full Udemy course, you'll get 13 detailed lessons covering all 4 patterns with code implementations, architecture blueprints for common use cases, performance benchmarks showing the impact of each pattern, and practical guidance on combining patterns for complex applications. Click the link below or scan the QR code to enroll and start building agentic AI systems. Thank you for watching. If you found this overview helpful, subscribe to the channel for more content, and check the description for the link to the full course. See you in the next video.